Hello, space enthusiasts. Welcome back to our channel. Today, we embark on an extraordinary journey to unravel the mysteries of Mars and discover a geological wonder that has captivated scientists and stargazers alike, the Mars Grand Canyon. Mars, the fourth planet from the Sun, is often called the Red Planet due to its rusty appearance. It's a terrestrial planet with a thin atmosphere, primarily composed of carbon dioxide. Mars has distinct features, including the largest volcano and canyon in the solar system. Valles Marineris is a system of canyons that spans 2,500 miles. At some points, the canyon is 125 miles wide. Regions can reach depth of 6 miles. If the system were located on Earth, it would stretch across the United States from Los Angeles to Atlantic coast. Valles Marineris is located along the equator of Mars on the east side and stretches for nearly a quarter of the planet's circumference. The canyon system starts in the west, proceeding to the east. Valles Marineris. The Grand Valley extends over 3,000 kilometers long, spans as much as 600 kilometers across, and delves as much as 8 kilometers deep. By comparison, the Earth's Grand Canyon in Arizona, USA, is 800 kilometers long, 30 kilometers across, and 1.8 kilometers deep. Besides just scale, Valles Marineris and the Grand Canyon differ in other ways as well. Flowing water from the mighty Colorado River formed the Grand Canyon as the water gradually eroded away rocks over eons. Scientists think Valles Marineris, however, is a huge tectonic crack in the surface. As Mars slowly cooled after first forming, the crust rose in the Tharsis region to the west, cracked and split as a result. Subsequent erosion continued to widen and deepen the crack into the canyon system we see today. Theories about the formation of Valles Marineris have changed over the years. Ideas in the 1970s were erosion by water and thermokarst activity, which is the melting of permafrost in glacial climes. Thermokarst activity may have contributed, but erosion by water is a problematic mechanism because liquid water cannot exist in most current Martian surface conditions. Many scientists, however, agree that liquid water flowed on the Martian surface in the past, when atmospheric conditions were different. Valles Marineris may have been enlarged by flowing water at that time. Another hypothesis by Macaulay in 1972 was that the canyons formed by withdrawal of subsurface magma. Around 1989, a theory of formation by tensional fracturing was proposed. There are, however, some outflow channels in the eastern portion of Valles Marineris that appear to have been formed by water. And indeed, there may still be some water left today below the surface. Few years before, scientists reported that the joint European-Russian Trace Gas Orbiter found evidence of water below ground in Valles Marineris. It is most likely in the form of ice. The most agreed upon theory today is that Valles Marineris was formed by rift faults, later enlarged by erosion and collapsing of the rift walls, similar to how the East African Rift was formed. The formation of Valles Marineris is thought to be closely tied with the formation of Tharsis Bulge. The first stage consisted of combination of volcanism and isostatic uplift. Soon, however, the volcanism loaded the crust to a point at which the crust could no longer support the added weight of Tharsis. The second stage consisted of more volcanism and loss of isostatic equilibrium. The source of regions of the volcanism no longer resided underneath Tharsis, creating a very large load. Finally, the crust failed to hold up Tharsis, and radial fractures formed, including at Valles Marineris. The third stage mainly consisted of more volcanism and asteroid impacts. Tharsis volcanism involved very low viscosity magma, forming shield volcanoes similar to those of Hawaiian island chain. But there is minor or no current active plate tectonics on Mars. Landslides have left numerous deposits on the floor of Valles Marineris and contributed to widening it. Possible triggers of landslides are quakes caused by tectonic activity or impact events. Glaciers, loosely defined as patches of currently or recently flowing ice, are thought to be present across large but restricted areas of the modern Martian surface and are supposed to have been more widely distributed at times in the past. To date, no proof of past or present life has been found on Mars. Cumulative evidence suggests that during the ancient times, the surface environment of Mars has liquid water and may have been habitable for microorganisms. But habitable conditions do not necessarily mean life. NASA and SpaceX both are working on human mission to Mars, making human colonization possible on Mars. Most recently, Elon Musk, the founder of SpaceX, said the company could land a spacecraft on Mars 3 to 4 years from now. According to SpaceX, the MCT system would indicate reusable rocket engines, launch vehicles, and space capsules that would enable transportation of humans to Mars and back to Earth. SpaceX has stated its ambition to facilitate the colonization of Mars via the development of Starship launch vehicle. The company claims that this is necessary for the long-term survival of the human species. NASA aims to launch astronauts to Mars by the late 2030s or early 2040s. Making that vision a reality will be challenging. The Orion capsule is specifically designed to keep humans alive during months-long missions and will be equipped with advanced environmental control and life support systems designed for the demands of deep space missions per NASA. And there you have it, the Mars Grand Canyon, a colossal testament to the geological wonders beyond our planet. If you enjoyed this cosmic journey, don't forget to like, share, and subscribe for more space exploration content. Until next time, keep looking up. Thank you for joining us on this interplanetary adventure. Stay curious, and until next time, take care.